All right, section 7.3, we're going to learn some more identities, some new identities, the double angle identities and the half angle identities. So here are the double angle formulas. The proofs of these are actually really straightforward. They follow as a direct consequence of the ones we did last class, the sine of x plus y, right? Well, I'll show you that here in a little bit, but I'll just point out that the proof I showed you on that last one, the cosine of a plus b, that's the only one that was really difficult. All the rest are really easy to prove after that one. Anyway, so the sine of 2x is equal to 2 sine x cosine x. Again, I should point out what's obviously not true. This does not equal 2 sine x, which is, I don't know why I even write that stuff down, because it's, but sometimes, every once in a while, there's a kid that's like, oh, I just could factor that 2 out in front. No, this is a double angle. Instead of taking the sine of 10 degrees, we're talking about taking the sine of 2 times 10 degrees. There's really no common sense reason why that would ever be equal to 2 times the sine of 10 degrees. It just doesn't work. Although it kind of looks like implied multiplication or something, but that's just, no. This is what we have instead. If you have a double angle, it's equal to 2 times the sine of x cosine of x. For the cosine of 2x, there's actually 3 different versions. Kind of the base version here is cosine squared x minus sine squared x. However, because we got sine squares and cosine squares, we could apply the Pythagorean identity, the sine squared plus cosine squared equals 1 to here, and kind of get 3 different versions of the same one. And it's nice to use different ones at different times. This one's only in terms of sines, this one's only in terms of cosines. And then for the tangent, we get 2 tangent x over 1 minus tangent squared x. So let's prove the sine double angle formula. Okay. I can only use formulas that I've proved before, so obviously I can't just say, oh, there it is, it's proved. But I can use the ones from the previous section, because we did prove those. So I'm going to start with the left-hand side. The sine of 2x. I'm really a stickler for starting with one side without changing it at all. So that, please do that when on your test. So I could write this as the sine of x plus x, because that's equal to 2x. And then I could apply my angle addition formulas from the previous section. So this is sine, cosine, cosine, sine, same sign. And we're done. Sine, cosine, cosine, sine. That is 2 sine, cosine. And we're done. Like I said, these all follow really easily from theorems from the last section. Okay? So I could similarly prove them all, but I'm not going to do that. Let me just do I want to talk about the theory types of topics on the video this time around, and I want to save the examples for class. So I'm going to do this one. Verify the trig identity. All right, so I got a sine of 3x. Now I don't have a formula for a triple angle. We could derive one if we wanted to, but it's not worth our time to memorize. In the rare case that we need to use it like this, we'll just figure it out. Left-hand side. I don't really have much I can do with this, and I'd have a really hard time to make this look like that. So of course we're going to start with the left-hand side. Sine of 3x over sine x cosine x. So I guess I could write this as the sine of x plus 2x over sine x cosine x. So I guess I'm applying, it doesn't really feel like I'm applying a double angle formula. I got to apply the angle addition again. Sine x cosine 2x plus cosine x sine 2x. Sine, cosine, cosine, sine, same sign. Sine x cosine x. So now I can apply the double the angle. So this is why I guess I put it on here. Now I can apply the angle addition formula 2 different times. Oh, so here's the question. Anytime you come up with the cosine, which version should I use? Usually one version is better than the others. But ultimately it shouldn't matter. It just might save you a step or two. For this I don't really have a choice. I got to use the sine of 2x. Sine of 2x is 2 sine x cosine x. So 2 sine x cosine x all over sine x cosine x. Alright, so let's see if we can look ahead here a little bit and try to figure out which is the best one of the three to choose for that one. Here I'm going to get a 2 sine cosine squared. I guess if I do the one that has the 2 cosine squared, that's I don't know. I don't think it really matters. I'm going to use the one with the 2 cosine squared because I think I kind of see something. So I'm going to put in 2 cosine squared x minus 1. Sometimes I miss these 3 up, to be honest with you. Okay, that's right. Alright, let's see how it cleans up. See what it does. So if I distribute this, I get 2 sine x cosine squared x minus sine x plus 2 sine x cosine squared x all over sine x cosine x. Okay, this didn't work out how I was planning. I was kind of thinking they'd maybe disappear, but they're obviously not. So this is 4 2 of these plus 2 of those is 4 of those. I'm getting a little nervous right now because I'm not seeing it anymore. What do we need to get it to look like? 4 cosine minus the secant. All right. Well, let's factor out the sine of x. That leaves me with 4 cosine squared x minus 1. Okay, so the signs cancel out, the signs go away, and I have 4 cosine squared x minus 1 all over cosine x. I'm going to separate that into 2 fractions, 4 cosine squared x over cosine x minus 1 over cosine x, which is 4 cosine squared x minus secant x. I think I got it. Okay. So this was, yeah, it was a longer proof. All right. And then we have our half angle identities. The half angle identities allow us to express half of an angle in terms of the angle itself. They're a bit more difficult to prove, but not too bad. Actually, we use the double angle formulas to prove the half angle formulas. We just do a substitution. However, these are more difficult to use and more difficult to memorize. I really do think they're more difficult to use, and we'll talk about those when we do the examples. What I'd like to do is really just maybe do 2 examples and then save the complexities for class. Okay. All right. So the sine of x over 2 or u over 2 is plus or minus the square root of 1 minus cosine u over 2. The thing that makes these a little bit difficult are these pluses and minuses. The identities don't really know which sign is supposed to be attached to the half angle of the sine of the half angle for the sine or the cosine. So we have to do that work on our own. That makes them more difficult. However, for the tangent, we got 2 versions and they don't have the plus or minus. So the tangent of x over 2 is 1 minus the cosine of x over sine x, or sine of x over 1 plus cosine x. The sign of plus or minus depends upon the quadrant which the half angle lies. Okay. So let's prove the sine of the half angle. For this one, it's going to be a different kind of proof. I'm not going to start with one side and work it to the other side. Or here, let me pause the video and think about it a little bit. Maybe I can do it with working from one side. So I looked at proving it where we work from one side and get to the other side, and I don't like it as much as this other proof, so I'm going to use a different technique for proving this. I'm just going to start with the double angle formula for the cosine. The cosine of 2 theta is equal to, and I'm going to use the one that's got the sine squared in it only. I'm going to use this one, 1 minus 2 sine squared x. Squared theta. So this I know to be true. So I'm doing this proof different than I've done the past proofs. In the past, I would just start with one side and I'd work with this one expression, justifying each step along the way until I get to the other side. But here I'm starting with an equation that I know to be true. So I'm just going to simplify and modify this equation to make it look like this one. It's a valid proof as long as you start with something that you know to be true. So that's what I'm going to do. So I don't want a double angle and a single angle. I want a half angle and an angle. So I'm going to let 2 theta equal x, in which case theta is equal to x over 2. So I'm going to do this little substitution. Where I see the cosine of 2 theta, I'm just going to put in an x under my substitution. And where I see theta, I'm going to put in the half angle. The idea here is we have a double angle formula that involves the sine and the cosine. Well, you can just make it a half angle by switching around your angles. This angle has got to be half of this angle. Why start at 2 theta and go to theta? We could start at x and go to half of x. Now, if I just solve this for the sine of x over 2, my proof is done. So I'm going to move this over here. 2 sine squared x over 2 equals 1 minus a cosine of x. Divide by 2. Sine squared x over 2 is equal to 1 minus cosine x over 2. I'm going to take the square root of both sides of this expression. I could maybe justify that it's okay to take the square root of both sides because both sides are positive, but I'm not going to. It's okay. So the sine of the half angle is equal to, and whenever you take the square root of both sides, you got to remember plus or minus square root of 1 minus cosine x over 2. And my proof is done. Yeah, that's it. Okay. This isn't what your proofs on the test are going to look like because I did this one a little bit differently. We're going to do ones like this one where you start with the left-hand side and you work it to the right-hand side. All right, got a minute and a half. I want to do one more example. So now we can find the sine of more angles. If you know the sine of 45 degrees, which we do, then you should be able to find the sine of the half angle, half of 45. So let's do that. The sine of 22.5 degrees is equal to the sine of 45 degrees divided by 2, because that is 22.5 degrees. So this is the half angle. I don't know my half angle formulas, so I'm going to use this one right here. It's 1 minus a cosine over 2. So this is plus or minus the square root of 1 minus a cosine of 45 degrees over 2. Right? The sine of x over 2 is plus or minus 1 minus a cosine of the angle on top divided by 2. I don't know the sine of 22.5, but I do know the cosine of 45, so I can evaluate this. It is plus or minus the square root of 1 minus, so what is the cosine of 45? That is 1 over square root of 2 over 2. So I got to figure out the plus or minus. Oh, I don't got 20 seconds. I'm not going to be able to finish it. Oh, dang it. Plus or minus the square root of... I only had 10 seconds, so I cheated. I worked it a step at a time to get to this answer. I want to talk about the plus or minus, but let's wait till class.